Good morning, everyone. Welcome to today's class. That is lesson number 5 of second module. We will just revise what was taught in the previous class before we start with today's class. Yeah. So, in the previous class, we started a new topic, compaction of soils. I told you compaction of soils is very important, and we are compacting soils in many civil engineering projects. When it comes to construction of roads, you have to compact the soil beneath the new surface of the road, and also when you are constructing embankments for bridges, you have to compact the soil if the embankments are made of soil. So, lot of highway projects, lot of embankments, even in earthen dams, we are compacting the soil. So when you are compacting the soil, it should be compacted properly. And to check whether the soil is compacted properly, you should know what is the maximum density the soil can be compacted and at which water content the soil achieves that density. So we'll check what is the field density and we'll compare it with what is the maximum density it can achieve. Yeah, that's why we are learning about compaction tests. So when you're compacting, you are adding water. You are adding water because water acts as a lubricating agent. Water acts as lubricating agent and it brings the soil particles together. Hence, it increases the density. Okay. But uh, if you go on adding water, okay, the density increases, but only up to a certain point. Beyond that point or beyond that water content, density won't increase, but density will decrease. So this is my point, and at this point, maximum dry density is achieved, and the corresponding water content is called as optimum moisture content. So, maximum dry density of a soil can be achieved at optimum moisture content. If you go on increasing the water content beyond the optimum moisture content, the density of the density of soil is going to increase because before the optimum moisture content, whatever water is added, it is used for lubrication and reorientation of particles. But the water added after the optimum moisture point, okay, it leads to separation of the particles, which leads to increase in the volume and which results in decrease of density. So this is the mechanism of compaction. So next, application of compaction. Now, before you construct any house, the soil beneath it is compacted. Whatever soil is filled into your the plinth up to plinth level, that soil is compacted. And compaction of soil, gravel, or crushed rock, or even you are compacting the bitumen, that is asphalt, when you are constructing roads or pavement. You are also compacting soil in earthen embankments. and you're compacting the soil behind the retaining wall. I had shown you in the first class what was a retaining wall, and we are compacting the soil backfill in trenches. I'll explain this later. And if the we are also compacting the soil during dam construction. So there are many applications of compaction of soil. The last two, construction of clay liners for waste storage area. Okay, your waste is dumped, whatever waste collected from your house, it is dumped in a site. If you go to in Dharwad, the waste dumping site is at okay, it is near Sailapur. Okay, the waste dumping yard. When you dump the waste, okay, all the liquid from the waste, it is called as leachate. It is a black liquid. Okay, now that liquid, okay, leachate is produced from the waste, and that liquid it tries to penetrate into the ground, and it will get mixed with groundwater. So that leachate should not penetrate the underground surface. That's why we are constructing clay liners at the dumping sites or the waste storage sites. Why clay liners? Uh, Clay liners because uh, clay, the permeability of clay is very low. Okay, water cannot pass through clay soils easily. Hence, if you provide a layer of clay, then it becomes very difficult for leachate to penetrate through the clay layer inside the underground surface. Next, for ground improvement, if the ground it has loose soil, so it is compacted. So these are the applications of compaction. Now, compaction, I told you the relation between density and water content increases up to certain point, and after that point it decreases, and that particular point is called as the water content at that particular point is optimum moisture content, and dry density at that particular point is maximum dry density MDD, and optimum moisture content OMC. Next, to find what is the maximum uh, dry density and to find what is the optimum moisture content, we are conducting compaction test, and the first test that we are conducting is standard Proctor compaction test. Okay. I had explained you what is a standard Proctor compaction test. Okay. You need a mold. Okay, you need a mold. Okay, that mold is made of three parts. This is the collar, which can be detached from the mold. This is my mold, and this is the base plate. Mold is attached to the base plate, and collar also can be attached to the mold. So all the three parts they are detachable from each other. So this is my mold, and we use a rammer. Now this is the weight. Okay, it can be dropped from a certain height. So we have a rammer, we have a mold, and the mold has three parts: collar, the mold, and the base plate. So this is my base plate, mold and collar. And we have rammer. I'll just show you the video.
Sure that we remove.
So we are taking soil passing through 4.75 mm and we are mixing it with water. So this is my mold. Okay, I can detach the collar and I can also detach. This is my base plate. With the help of these screws, I can detach the base plate from the mold. So first I'll take the empty weight of the mold. Okay, before I take the empty weight of the mold, I should measure the volume of the mold. How do I measure the volume of the mold? I will measure the diameter of the mold, and I will measure the height of the mold. So area into height will give me volume. So volume of the mold is taken, empty weight of the mold is taken, then we'll start the experiment. So let's say first we'll take 4% of water. So if I'm taking 2000 grams of soil, uh, if I want to add 4% of water, then I have to add 4% of 2000 is 80. 4 divided by 100, whole multiplied by 2000. You will get 80 grams. So for 2 kg or 2000 grams of soil, if I want to add 4% of water, then that means I have to add 80 grams of water or 80 ml of water. So now I'll take soil, I'll take 2 kg of soil or 2000 grams of soil. Then I will add 80 grams of water or 80 ml of water. I can take the weight of water or I can add the water using a measuring cylinder. The density of water is 1, so 80 grams of water means 80 ml of water. So I'll add 80 grams of water. Next, I'll I'll mix it properly. After mixing the soil, okay, I'll take some soil in the mound. So this is my rammer. Its weight is 25 Newton or it is 2.6 kg. So I'll first put the soil in the mold such that after compacting the soil, it will fill 1/3 of the mold. So I'll take my mold. I have taken some soil in the mold. I'll start giving blows. So this is my rammer. I'll start giving blows. I have to give 25 blows, and all the blows must be distributed uniformly across the soil surface. So I'll give 25 blows uniformly across the soil surface, and after compacting, okay, the layer should approximately fill 1/3 of the mold. Okay, we are compacting in 3 layers, so it has approximately filled 1/3 of the mold. Next, we'll take some more soil and we'll again fill the soil such that after compaction, approximately it should fill two-thirds of the mound. Okay. So again, we have filled the second layer. Now we'll compact the second layer using the primer. Again, for the second layer, we are giving 25 blows, and all the 25 blows must be uniformly covered. All the okay. So this is my second layer. It approximately fills two-thirds of the mound. Next, I'll take my final layer. I'll add some more soil and I'll fill it up to this point so that after compaction it approximately fills full mold or a little more than full mold. Again I'm giving 25 blows for the third layer. Now after giving 25 blows it must fill complete mold or just 1 centimeter or 1.5 centimeter more than the mold. So I'll detach the collar. Now we can see it is slightly more than the top level of the mold. So I'll trim it off. I'll trim the extra soil exactly to the top of the mold. Next, I'll clean my mold. I'll clean the base plate. And I will take the weight. Earlier, I had taken the weight of empty mold with base plate. Now I'm taking the empty mold with soil. Now it is 6,200 grams. So similarly, we'll do it for different number of different. We'll do it for 4 to 5 trials, increasing the percentage of water. First we had added 4%, then we'll add 6%, 8%, 10%, 12%, so on for the next trial. After each trial, we'll take some sample out of the compacted mold, compacted soil, and we'll keep that soil for water content determination. So you know how to do water content determination using oven. We'll take the weight of empty container and we'll take some moist or wet soil inside the container and again take the weight and we'll keep this moist or wet soil in the oven. So this is done for 4 to 5 times. So we'll take out the soil from the mound and again we'll add 2% of water. So this is my experiment. After I conduct my experiment, I will get I'll have this tabulation. First I'm measuring volume of the mold. Second I'm measuring weight of the mold. Next I'll take weight of the mold plus soil. Weight of soil, weight of soil is calculated as W2 minus W1. Okay. And next we are calculating bulk density of soil. So first weight of wet soil is calculated as, let us indicate weight of wet soil as WS. This is calculated as W2 minus W1. Next, bulk density is calculated as, let's say this is my bulk density. If it is unit weight, we'll denote it as gamma. If it is density, we'll denote it as rho. This is density and this is my unit weight. So all my weights are in terms of grams. So I will get density. So I'll denote it as rho. So rho is equal to weight of soil divided by volume of mold. Now volume of mold is given by, it is given by area into height, and area is given by pi divided by 4 into d square. Pi divided by 4 into d square is my area of the mold, cross section area of the mold, multiplied by height of the mold will give me volume. Next, I have calculated bulk density. Now I have to calculate dry density. And to calculate dry density, I need water content. So I'll take empty weight of the cup. Next, I'll take weight of the cup plus weight of wet soil, and then I'll keep it in oven. I'll take weight of cup plus dry soil. I can calculate water content by oven drying method. Okay. So after I calculate water content, I can calculate dry density. Dry density is given by, we have this formula. Uh, Dry density is equal to, okay, bulk density divided by 1 plus W. So bulk density we have calculated here, and water content we are calculating using oven drying. So this is in terms of unit weight, but here I have density. So density is rho. It is denoted as rho density. Dry density is rho in rho d. And dry density is given by bulk density divided by 1 plus W. Okay, now please note that all the weight will be in terms of grams, and the volume we are measuring in terms of centimeter. So volume will be in terms of cubic centimeter, cc, or centimeter cube. So density will be in terms of gram per cc, gram per centimeter cube. So bulk density and dry density will be in terms of gram per centimeter cube. Uh, so this is a standard compaction test. You will understand this much better when we are solving numerical problem. So this is my standard compaction test. Now, let us go to the next test, modified compaction test. Now, why we have two types of testing? We have standard test and we have modified test. Why we have two types of test? Because okay, modified compaction test is conducted when we are expecting heavy loads on the soil. Let's say you are constructing airfield. Okay? You are constructing an airfield to support heavy aircrafts. So you have to conduct modified compaction test. Uh, or if you are constructing runway, all of you know what is a runway, right? We have runways in the airport. The planes uh, run on that particular pavement for some time before flying into the air. So we have runways and aeroplanes. They are of they are very heavy compared to the vehicles that are running on the road. So if you are constructing a runway where you are expecting the plane to travel, then the soil that is compacted beneath that runway to check that particular compaction or to check the maximum dry density and optimum moisture content of uh, that particular soil, you must conduct modified Proctor test or modified compaction test. Okay. So please remember this: modified compaction test or modified Proctor test is conducted when we are expecting heavy loads. So what is the difference between standard Proctor test and modified Proctor test? Okay. The difference is in standard Proctor test, okay, the hammer is dropped from a height of 305 mm or 310 mm, but in modified Proctor test, the hammer is dropped from a height of 450 mm. Next, in standard Proctor test, we are giving the weight of the rammer is 25 Newton, that is 2.6 kg, but in modified Proctor test, the weight of the rammer is heavier, that is 45 Newton, that is 4.5 kgs. But okay, in standard Proctor test, we are giving 25 blows per layer. In modified Proctor test, also we are giving 25 blows per layer. But in standard Proctor test, we are compacting soil in three layers. In modified Proctor test, we are compacting soil in 5 layers. So I showed you a video. They were compacting soil in 3 layers, but in modified Proctor test, they are compacting soil in 5 layers. But each layer they are giving 25. Now, the mold used for standard and modified Proctor test, it is same. It is that 1000 ml or 945 ml mold, but the compaction energy, the energy with which the soil is compacted, it is more in modified Proctor test. In standard Proctor test, it is 605,160 Newton mm per meter cube, but in modified Proctor test, it is 2,726,000 Newton per Newton mm per meter cube. So how compaction energy is calculated? It is number of blows per layer, okay, into number of layers into weight of hammer into height of the drop of hammer divided by volume of the mold. So if you calculate compaction energy, okay, for standard compaction test, it will be Number of layers for standard compaction test is, number of blows for standard compaction test is 25, and number of layers for standard compaction test is 3. Weight of hammer is 25 Newton. So weight is 25 Newton, and height from which rammer is dropped is 305 mm, or it is 310 mm. And it is divided by volume of the mold. Now, volume of the mold, it is not constant. It is approximately 945 ml, or you can even take it approximately as 1000 ml, or you can take it as 950. It is not exactly 945. It is around that value. So I'll take it as 945. So it is in terms of centimeter cube, and this height is in terms of millimeter. So if you convert this mm into centimeter, or if you convert centimeter cube into millimeter cube, you will get this value, 605,160 Newton mm per meter cube. Okay. So if you keep this in Newton, if you keep this in mm, and if you take this in terms of meter cube, then you will get 605,160 Newton mm per meter. Similarly, for a modified Proctor test, number of blows per layer, it is 25, and we are compacting in 5 layers. So 5 layers. In modified Proctor test, uh, the weight of rammer is 45 Newton, and the height from which it is dropped, it is 450 mm height. So it is dropped from a height of 450 mm. The weight is in terms of Newton. And volume of the mold remains same. It is 945 centimeter cube. So this is how compaction energy is calculated. Okay. Uh, the thing to note here is compaction energy of modified Proctor test is 4.5 times that of standard Proctor test. So in modified Proctor test, the compaction energy is more because heavy loads are expected. That's why we are putting a lot of energy when we are conducting the compaction test. Please remember, the compaction energy is 4.5 times that of standard Proctor test. And we have two tests. We have two tests because modified Proctor test is conducted when heavy loads are expected. Examples of heavy loads, when we are expecting, okay, like we are constructing runways and we are expecting weight of an aeroplane to land on it, or when we are constructing expressways, okay, or when we are constructing uh, roads, military roads, where heavy heavy weight vehicles like tank, army vehicles are expected to run on that roads. So please remember, modified Proctor test is conducted when heavy loads are expected on the uh, soil. Okay. Any doubts? What is modified Proctor test, and why is modified Proctor test conducted? Any doubts? Okay. Fine. Please remember why modified Proctor test is conducted. It is conducted when heavy loads are involved. And remember the difference between standard and modified Proctor test. Okay, in standard Proctor test, we are compacting the soil in three layers. In modified Proctor test, we are compacting the soil in five layers. Okay, and the height from which the rammer is dropped, it is 305 mm in standard Proctor test. It is 450 mm in modified Proctor test. And we are using 25 Newton rammer, 25 Newton or 2.6 kg in SPT, and in MPT we are using 45 Newton hammer or 4.6 kg hammer. The mold size and number of blows given to one layer are same in both the cases, but the energy given in modified Proctor test is more. It is approximately 4.5 times that of standard Proctor test. So this is today's lesson about modified Proctor test. Similar to standard Proctor test, there are only few differences. Any doubts? Any doubts regarding today's lesson or your first internals? Yeah, I haven't checked your answer sheets, but I'll again repeat, this is a very important subject, geotechnical engineering. Make sure you learn it. Okay, you have to put efforts and you have to. Okay, I wanted to show you something. I'll just wait 2 minutes. Okay, that's it for today's class. Thank you. Thank you for listening.